Has anyone solved this problem, 10th problem? Yeah, has anyone solved the 10th problem? Yes or no? Has anyone solved this 10th problem? Yes or no? Yeah, anyone, any doubts in the previous topics? Okay, anyone solved this 10th problem? Anyone got the solution? Okay, so I hope no one got the solution. Okay, yeah. So I will be explaining this 10th problem. Yeah, you have two planes. One is vertical plane and another one is horizontal plane. Okay, one is vertical plane and another is horizontal plane. On the vertical plane, you can see the front view. On the vertical plane, you can see the front view of an object. On the horizontal plane, you can see the top view of an object. On the horizontal plane, you can see the top view of an object. In order to see the side view of any object, you need to have the profile plane. You need to create one more profile plane. So this plane is called profile plane or auxiliary vertical plane. There are two names. One is profile plane or auxiliary vertical plane. On this plane, you can see the side view. And there are two types of side views. One is left hand side view, right hand side view. So this is, you are seeing from the right side of the object. So this will project as right hand side view. If you create the same one more plane here, and if you see from this side, it will become as left hand side view. Okay. So as the problem says, can one tell me what is the H value? Yeah. What is the H value? Positive or negative? Yeah. My voice is audible?
Yes, sir.
Yeah. What is the H value? Can anyone tell me? Read the question. What
Plus 50.
H value is plus 50. Okay. What is the D value?
Plus 30.
Plus 30. And what is the HD, which is nothing but the side view? What is that value?
Plus 20.
Plus 20 they give. So the letter is P. The point we are projecting is the P. This P will be projected as, in H, how it will project capital letter P with respect to H? H is nothing but the front view. For the front view, what will be the projection? How the P will project? Whether it is the P dash or P double dash, H will project.
P dash.
It is P dash. And what is the value for D? Letter D. D is nothing but the top view. For the top view, how it will project? It will project as small letter P. And for the HD, it is nothing but the for the side view, it will project as the P double dash.
P double dash.
Small letter P double dash. So my point is somewhere here. My letter P, capital letter P is somewhere here. And this is my H distance with respect to the ground level of this one. This is my H distance and this is my D distance. So on the H distance, it will project as the letter P dash. In the top, it will project as letter P, and this is my D distance. Okay. And with respect to this with respect to this H will be projected as P dash, small letter P dash. And whatever this H, vertical H, will be same projected here. This is also same 30, 50 value. Okay. And whatever may be this distance, D distance is plus 30, and this is the same 30 will be projected here. Okay. And from here to here, this is my P double dash. P double dash, and this distance is HD value. And whatever may be this distance, this will be the same distance. This distance is plus 20. Okay. And we know that this is my 30 mm distance. This 30 mm distance, again, it will be projected here. So this will be 30. Okay. And whatever may be this vertical height H, same thing will be projected here. This is my H. And whatever may be this distance is 20 mm. The same 20 mm will be coming here. Okay. So whenever you are drawing, you will be rotating this one into the rotating clockwise. You will be rotating the horizontal plane to clockwise, and you will be rotating the profile plane to the counterclockwise direction. So whenever I am projecting, this is my XY line. This is my XY line, and this is my X1 Y1 line. This is my X1 and Y1 line. So first thing, I have to draw my XY line. First step, I have to draw my XY line. Next step, I have to draw my X1 Y1 line. Okay. So next step, I am drawing my X1 and Y1 line. Then I know that this distance, this is X1 Y1 line. With respect to X1 Y1 line, this distance is in front of 20 mm in front of profile plane. So because of this reason, I am taking this as 20 mm. 20 mm, and this vertical height should be 50. And I should measure that this vertical height should be 50. Where the vertical 50 line and horizontal 20 lines are meeting, at that point I will be marking my point as P dash. At that point I will be marking my point as P dash. And next, this is my 30 mm, which is the D distance. H is positive, therefore it is above XY line. And D is positive because it is therefore it is below XY line. So I will take my 30 mm. I'll take this vertical distance as 30 mm, and I'll mark my point as letter P. Okay. And with after X1 Y1 line, the distance is 30 because this distance is 30. So same distance will be given here. So from this distance, you have to take this as the 30. You have to take from the X1 Y1 line, you have to take a distance of 30 and mark the point as P double dash. And mark the point as P double dash. So this is my side view. This is my front view, and this is my top view. So if I want to join my top view and side view, because already my front view and side view are joined, and my top and my front view and my top view are joined. If I want to join my top view and side view, what I have to do is I have to extend this distance. I have to draw the vertical line. From here, I have to draw the horizontal line. Okay. Then if you measure this distance, you have to keep a compass, measure the distance, keep a pointer here, and radius is 30. And then you have to join this one with the compass. There is another method also. If you want to join these two things, you can take an inclination of 45 degrees. You can inclination of 45 degrees. Then what you can do is, when you take the inclination of 45 degrees, then project this vertical line. Wherever this vertical line is touching, and this vertical line will join each other. That is the method to draw this one. So here you are locating the P dash, P and P double dash. P dash is nothing but the front view. P is nothing but the top view, and P double dash is nothing but the side view. Okay. So you have to take the 45 degrees. 45 degrees angle you have to take, and if you draw this one, it will become a square. Okay. So that's the reason you will be taking 45 degrees line, so that you have to extend this line. If you take the 45 degrees line, directly draw the vertical line where it is cutting the 45 degrees line, and draw this horizontal line where it is touching the 45 degrees line, both with meet at a single point. Okay. Or else you have to take a compass. We draw this one whenever our compass radius is not sufficient to draw. Whenever our compass radius is not sufficient to draw the arc, draw the radius, then what we do is we take 45 degrees line and we join this vertical line and this vertical line. It will join that point. Therefore, all the points are joining each other. Okay. So look at the video. So this is your point. So this is your thing. So this is your front view. You are seeing this is the front view, this is the top view, and this is the side view. So the point is somewhere here. It is, as per the problem, it is 50 mm above the horizontal plane, and it is 30 mm in front of this vertical plane, and it is 20 mm in front of this profile plane. Okay, so point is somewhere here. So it is 30 mm, it is 50 mm vertical, 30 mm to vertical plane, and 20 mm in front of the horizontal plane. So what we do is, we, in order to see, and observers should see, so that's the reason what we do is we rotate this one down and we rotate this one down. So all the points should join, side view and front view will join horizontally, and the front view and top view will join vertically. Okay, and this will be, there's a gap between, so we will be taking a curve, or else we draw a 45 degrees line here and we join this step here. Okay. Yeah, any doubts you can unmute and you can ask. If any doubts, you can unmute and you can ask. If no doubts, I will be showing you the solution. Okay. So this is my point P. If I project P dash, if I project to side view P double dash, if I project down, it is P dash. This is my left side of the object. So this is my left hand side view. This is called left hand side view. We call this as left hand side view. And this is my top. So top will be projected here. This is my front. My front will be projected here. So I have to overlap. I have to draw the XY line. I have to extend my XY line. I have to draw my X1, Y1 line. This is my X1, Y1 line. I have to draw two things. XY line, X1, Y1 line. And from this distance, I have to take this as 20. From vertical height, I have to take 50. Then again, I have to take a horizontal distance 30. I'll mark this point as P double dash. I'll mark this point as P dash. I'll project at a distance of 30. I'll mark the point as P. In order to join these two, I can take a 45 degrees line, or I can take a compass. If I have a compass without any errors, then I can directly join the compass, or else I'll take a 45 degrees line and I project this line till here and I project this line till here, then it will be joined. Okay. So if you see the solution, this is your solution. You have to draw XY line, X1, Y1 line, 50, 30 and 20. And what are these 30? Same 30 will be projected here. This will be 30 and this will be 20. And this vertical height will be 50. So you can join. If you want to join these two, take a 45 degrees line, project this till here and project this till here. Then it will be joined at a 45 degrees line. Okay. Or else take a compass, radius, point here and draw the arc. It will join these two points. So you have to join these two things. Suppose if you know the side view and you don't know the length of this one, then you can use this method, either 45 degrees line or take a compass and join them. Okay. Yeah, any doubts you can unmute and you can ask. If any doubts you can unmute and you can ask. There are total 10 problems in sheet 5. You need to submit sheet 5 by Monday. Okay. You need to submit sheet 5 by Monday. I will be creating the Google assignment so that you can submit your drawing sheet by Monday. And those who haven't joined the Google Classroom, compulsory join the Google Classroom. Any doubts you can unmute and you can ask. Yeah. Any doubts in the previous sheet projection of points, you can unmute and you can ask. So now I will be starting the projection of lines. This is sheet number 6, unit number 2, last part of unit 2. So if sheet projection of straight lines completed, then we can go to the third unit. So this is our second unit. So there are two topics in the engine drawing, sheet number 6, projection of straight lines. One is a line, projection of line inclined to one plane, inclined to any plane, whether it is can be inclined to the horizontal plane, vertical plane, or profile plane. And projection of line inclined to both the planes. If the same line is inclined to vertical plane, horizontal plane simultaneously, what is the inclination? So these are the two topics you can expect, and this topic you can expect as a 2 marks question, or A bit B bit as essay question. But the projection of inclined to both the planes you can expect as directly as 10 marks. You can directly expect 10 marks for the project inclined to the both the planes. Okay, and in order to understand this topic, in order to understand this essay topic, you have to understand this topic. Projection of line inclined to one plane, you have to understand. If you understand this topic, then only you will be understanding this topic. Okay. So don't be absent for any of the class. Yeah. Introduction. So I hope everyone know a line. If I create a line, I have to give the labeling for that line, either AB, because line has 2 points, minimum 2 points a line has. So starting point is A, ending point is B. They can give anything in the problem. They can ask PQ, draw a PQ line, they will ask. So the starting point of line will be letter P, and the ending point of the letter will be become Q. Okay, so A, B, P, Q, they'll give anything in the exam. Okay, so a line is nothing but when you join 2 points, a line is created, and the line can be anything. Line can be horizontal, line can be vertical, line can be inclined. Anything can be possible in the lines. Okay, so whenever I say line, don't think that it is a horizontal line. It can be anything. It can be horizontal line, it can be a vertical line, and it can be a inclined line also, depend upon. Okay, so for everything you have to give the labeling A, B, P, Q, or any other words what are given in the problem. You have to use those words. Okay, and for a line, it will be capital letters, and if a line is projected on the, okay, so I'll be again drawing. So this is my horizontal plane and vertical plane. So this is my vertical plane, and this is my horizontal plane. Okay, this is my horizontal plane. Suppose my line is in the top view. Suppose my line is the top view, then I have to write AB line. So then I have to write small letter AB. Okay. Suppose if on my vertical plane, my line is vertical. So this is my front view. So I have to write P dash and Q dash, small letter P dash, small letter Q dash. Okay. Suppose this is my side view, which is nothing but the profile plane. This is the profile plane. So for the profile plane, if a line is inclined, example, suppose I have to write this as small letter A double dash and B double dash, because on the HP plane you will be getting the top view. Top view you have to write small letters. On the vertical plane you will be getting the front view. You have to write P dash and Q dash, small letter and dash you have to write. On the profile plane you have to write it as small letter double dash, small letter double dash. For the 2 points you have to write. Okay, that is the main thing you have to understand. If you're not giving this labeling A double dash or B double dash on the profile plane, A or B on the horizontal plane, P dash and Q dash, example like P dash and Q dash, if you're not giving, marks will be reduced. And there are some inclination angles. If I want to make an inclination, there will be certain angles such as theta, alpha, beta, gamma. Those angles you need to understand. Why those angles are there, you need to understand before starting the projection of straight lines. And I also told you to write the theory part. Compulsory write the theory part. If you write the theory part once, then only you will be understanding. Okay. Yeah. A straight line is defined as the shortest distance between 2 points. Suppose I have 2 points. If I join these 2 points, it will become a line. That is this one. And this is a one dimensional. It has only one dimension, either length or width or thickness. Okay. When it has length, it doesn't have any thickness. Whenever we say a line, it has no thickness. It has only the length value. Straight lines are drawn by joining two respective projection of endpoints. So initially you need to have two endpoints, endpoint A and endpoint B, or endpoint P or endpoint Q. If you join those endpoints, then you will be getting a line. Okay. And line may be different orientation. It can be parallel. Okay, it can be, suppose this is my horizontal plane. Okay, so wait, I'll be drawing again. So this is my vertical plane and this is my horizontal plane. Okay, so it may be parallel to the plane. So this is my plane, this is my vertical plane. It can be parallel to the plane. It is parallel, but this line and this line are same parallel, or else it can be perpendicular to the plane. So with respect to vertical plane, this is my perpendicular because this is my horizontal plane and this is vertical. So it is vertical to the vertical plane. And with respect to horizontal plane, this is parallel to horizontal plane and this is perpendicular to horizontal plane. And with respect to the profile plane, this is parallel to profile plane and this is perpendicular to profile plane. Okay, or else it can be inclined, such a way that this is parallel. For the parallel, I am taking at an angle. So this is the inclined to the profile, inclined to the vertical plane. So already this is my horizontal plane, which is parallel to the horizontal plane. If I take an angle, it is inclined to this horizontal plane. So already this is my parallel to profile plane. If I take any angle, this is the inclination to the profile plane. Okay, so anything can be possible. The orientation can be parallel, perpendicular, or inclined to one plane or both the planes. Okay, so these things you have to remember. Line can be horizontal, perpendicular, or inclined to any of the planes. Okay, I will show you how those are inclination. Okay, so everyone watch the video. I am stopping the share. So everyone watch the video. Yeah. So watch my video carefully. So this is my horizontal, this is my vertical plane, this is my horizontal plane, and this is your profile plane. Your profile plane will be like this. You can't see anything, only the line you can see on the profile. This is your profile plane, this is your vertical plane, and this is your horizontal plane. So whenever I say the vertical plane, so suppose this is a line, AB. Starting point is A, ending point is B, line AB. Then this is my vertical plane. Whenever I say parallel to vertical plane, it is like this. This line and this line are parallel to each other. So this is my parallel to vertical plane, and with respect to this line and this line, it is parallel to vertical plane. So two cases are possible whenever I say parallel. Either this is parallel to vertical plane or this is parallel to vertical plane. And whenever I say perpendicular, this is my perpendicular to vertical plane because it is 90 degrees to the plane. This is my perpendicular, this is my parallel to vertical plane, this is my parallel to vertical plane, and this is perpendicular to vertical plane. And whenever I say inclination to vertical plane, it can be anything. This is my parallel, then I am lifting like this. Whenever I am lifting like this, my pen, this is the inclination at an angle. So this is my angle, inclination. Now line is inclined to vertical plane. Similarly, this is my parallel to vertical plane. Whenever I say inclination, it can be like this. Whenever I am giving an angle, already it is 0 degrees. Now I am giving 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 is perpendicular. Okay. So this is my 0 degrees line. Now I am giving 10, 20, 30, 40, 50, 60, 90. 90 is my perpendicular. So whenever I say perpendicular, this parallel is rotating 90 degrees and this parallel is rotating 90 degrees. So both are 90 degrees to this vertical plane. Okay. Similarly, coming to horizontal plane, this is my horizontal plane. And if I place my line like this, then it is parallel to each other. It is parallel to this side. It is parallel, or it is parallel like this. Okay. And whenever I say perpendicular, it has to rotate 90 degrees. So this is my 0 degrees line. It has to rotate 10, 20, 30, 40, 50, 60, 90. So this is my perpendicular to horizontal plane. Suppose this is my parallel, then I have to rotate this as 10, 20, 30, 40, 60, 90. So this is my perpendicular. So whenever I say this is 90 and this is 90. So parallel can be two cases. This is also parallel to horizontal plane. This is also parallel to horizontal plane. Okay. And this is 90 degrees. This is exactly 90 degrees. It can be, you are rotating this to 90 degrees. I'm rotating this to 90 degrees. So both are 90 degrees to horizontal plane. And similarly, this is your profile plane. This is your profile plane. So whenever I say profile plane, this is parallel to profile plane, and this is also parallel to profile plane. Okay, this is parallel to profile plane, and this is also parallel to profile plane. And what happens is, if I want to rotate, if I want to make this line perpendicular, then I have to take 10, 20, 30, 60, 90. Then I'm making this is parallel to my profile plane. And if you see this case, this is my 10, 20, 30, 40, 50, 60, 90, and this is parallel. This is perpendicular to profile plane. Okay. So this is perpendicular to profile plane, and this is also perpendicular to profile plane. Okay. So those things you have to understand. Okay. I'll explain in this also. So if you see this one, this is your horizontal plane and vertical plane. This is your horizontal plane and vertical plane. This is my horizontal plane, and this is my vertical plane. Okay. So whenever I say parallel, if there are two cases, either my line can be like this or like this. Both are parallel to HP. This case is parallel to HP and this case is parallel to HP. And whenever I'm making perpendicular, to horizontal plane, it is automatically parallel to vertical plane. Whenever I'm making perpendicular to horizontal plane, it is automatically parallel to vertical plane. Okay. So this is parallel. So whenever I'm making parallel to vertical plane, it will be perpendicular to horizontal plane, because these both angles are 90 degrees, because the vertical plane and horizontal plane are both at an angle of 90 degrees. Whenever I'm making parallel to vertical plane, it is automatically perpendicular to horizontal plane. And whenever I'm making parallel to horizontal plane, it is automatically making perpendicular to vertical plane. So in cases, some cases, what happens is, whenever a line is parallel to horizontal plane, it is automatically perpendicular to vertical plane. And whenever a line is parallel to vertical plane, it is automatically perpendicular to horizontal plane. Okay, these things you have to understand. Okay. Any doubts, you can unmute and you can ask. If any doubts, you can unmute and you can ask, because this is important topic. If you understand this topic only, you will understand the other topics. Okay. Yeah, any doubts, you can unmute and you can ask. I'll wait for 1 or 2 minutes. Any doubts, unmute and you can ask. And if any doubts, watch this video once again. I will share today's class video again in our WhatsApp group. So watch it once again. If you have any doubts, watch it once again, so that it will be clear. Okay. Yeah. Any doubts, you can unmute and you can ask. Any doubts, you can unmute and you can ask. Okay, so I'm sharing the screen. We'll be starting the theory part. Okay. So there are few terms which we use in the projection of straight lines. So the first term, true length. So true length is nothing but, true is nothing but your actual. True is nothing but actual. Length is nothing but your distance of the line. Okay. True is nothing but the actual length of a line, known as true length. So sometimes what happens is, it depends on perspective. Suppose this is my vertical line. If anything is parallel to each other, suppose this is my vertical line. Suppose this is my vertical plane. On the vertical plane, I am drawing exactly 90 degrees. Okay. I'm drawing exactly 90 degrees. So I can see the true length. I can see the true length. True length is projected here. And this is my parallel. Then I can see, suppose my line is somewhere here. Then I can see my actual length here. But sometimes what happens is, whenever I make an line inclination, you can't see the true length.
Yes.
Yeah, whenever I can make the line as an inclination, you can't see the true length. The line will be reduced. So either the length will be, either the length of the line should be true length or less than true length. It will be true length, or it will be less than true length or equal to true length whenever a line is projected. Okay, those things you have to understand. True length is nothing but what are the actual length of a line. Because suppose my pen distance is about 100 mm. Example, my pen distance is 100 mm. This is called true length. Whatever angle I rotate, whether it can be horizontal, perpendicular, inclination, any inclination, the true length will be same. But when I'm making the projection, the length will be reduced. It won't be increased, it will be reduced. Either it will be reduced or it will be show the true length, whatever the projections you are making. Okay. Next, plan. So when we are discussing the projection of points, I told that top view is also called as plan. So in the problem, they'll ask show the plan length. So in the exam, they show the plan length. Plan length is nothing but the top view length. And when I am discussing projection of points, I told that elevation length. This elevation length is called as the front view. This elevation length is called as the front view. Okay. So listen carefully. So in the exam, in the problem, if they ask the plan length, it is nothing but the top view length you have to understand. Okay. It is the apparent length of a line seen in the top view. So whenever you are seeing a line in the top view, that is called as the plan length. Okay. So whatever may be the line, if you are seeing on the top view. So top view you can see on the HP plane. On the HP plane, you can see the top view. Whenever you are seeing any line, this is called plan length. We have to represent this as PL. PL is nothing but the plan length. So whenever you write PL, I will understand that it is a top view length. Okay. So here don't write top view length. You will writing it as PL. PL is nothing but the plan length or top view projection of the line. And whenever you are writing EL, EL is nothing but the elevation length. It means that you are representing the front view length. Whenever you are representing front view length, you have to write it as EL. And whenever you are projecting the top view length, you have to write it as plan length. Okay. Yeah. So apparent length seen in the top view. Okay. So this is my book, which is a horizontal plane. So whatever I'm seeing, so look here. So I'm stopping the share. So once look here. So I told that it is a plan length. So plan length is nothing but this one. So if you see on the top view, you can't see the complete length. Can you see? Yeah, whenever you are seeing the top view, this is your top view, and this is your actual length of the pen. Suppose the pen length is 100 mm. So this is actual length. But when you're seeing the top view, you can see only a dot. This is only 0 to 1 mm will be there in between 0 to 1 mm. So this is your top view. So top view will be just a point. This is not true length. You are not seeing the true length of the top view length. Top view length will be 0 to 1 mm, but actual length of the pen is 100 mm. Okay, that is the difference. You are saying the top view length or plan length. Okay. So I'm sharing the screen. So that's the reason what happens is. If a line is parallel to HP, plan length is equal to true length. Plan length equal to true length, because this is my parallel. So this is my HP and this is parallel. Whenever it is parallel, I can see the complete length. on the horizontal plane. And whenever it is any inclination other than any inclination is 90 degrees inclination. So it is perpendicular. So whenever it is perpendicular, or if I given any angle such as 0 degrees, 1 degree, 2 degree, 3 degree, then the true length will reduce. So this is my true length on this one, 100 mm. If I rotate, suppose 10 degrees, the 10 mm is reduced. If I rotate 60 degrees, 60 mm is reduced. If I rotate 90 degrees, it will become 0. And again, if I am rotating 100, 110, 120, again it will increase. whenever I'm keeping 90, it will become 0. And again 110, it will increase. And you can, whenever it is again rotated from this side to this side, if you rotate it, you can see the complete true length of the pen. Okay. So whenever a line is inclined, whenever I'm making an inclination to HP, then plan length is less than true length. True length is 100 mm. True length is 100 mm. The plan length will be reduced, less than it will be. Okay. So we can say that true length can be either less than or equal to true length. Okay. The plan length will be less than or equal to true length. Whenever we given any inclination, 1 degree, 10 degrees, 20 degrees, 30, 60, 90, whenever we are giving inclination, the length will reduce. Okay. Maximum length is true length. Either the plan length will be equal to true length if it is parallel to HP, or it will, whenever it is inclined, it is plan length is less than true length. Okay. And next one, elevation length. Elevation length is nothing but the front view length. Elevation length is nothing but the front view length. It is apparent length of a line of a front view. So whenever I'm seeing a line in the front view, so this is my vertical plane. Whenever I'm seeing any line in the front view, this is my elevation length. This is my elevation length. Whatever the line I'm seeing, this is my elevation length. And same principle is applied here. If a line is parallel to vertical plane, whenever a line is parallel to vertical plane, then elevation length equal to true length. Whenever the line is parallel to VP, then elevation length equal to true length. And whenever a line is inclined to VP, then elevation length is less than true length. Then elevation length is less than true length. Therefore, I can say that elevation length is either less than or equal to true length. Therefore, I can say that elevation length is either less than or equal to true length. Okay. Whenever line is parallel to HP, then plan length equal to true length. Whenever line is parallel to VP, elevation length equal to true length. And whenever line is inclined, any inclination, whether 0 degrees to 1 degree to 89 degrees, whenever there is inclination, plan length is less than true length. Similarly, elevation length is less than true length if there is any, if the line is inclined to VP. Okay. Yeah. Yeah, I will take the attendance. Everyone raise your hands. Anyone not raising the hand will be marked as absent. I will give only 30 seconds to raise your hands. Within 30 seconds, you have to raise your hands. Yeah, only 24 members raised. 25. Anyone not raising the hand will be marked as absent. And this is important topic. You have to listen. If you are not listening, it is difficult to pass this drawing subject. Yeah, still roll number 7, 11, 17, 22, 26, 27, 32, 33, 34, 36, 49, 51, 59, 16. If you are not raising your hands, will be marked as absent. Yeah. I am lowering all the hands, attendance completed. Again, I will ask to raise at the end of the class. At that time, if you are not raising, you will be marked as absent. Okay. Yeah, any doubts, you can unmute and you can ask. If anyone, any doubts, you can unmute and you can ask. Whenever I give inclination, the length will be reduced. If I give any small inclination, the length will be reduced. Yeah. Any doubts, you can unmute and you can ask. If anyone has any doubts, you can unmute and you can ask. If no doubts, I'll start the next topic. So understand only one thing, that whenever line is parallel to HP, plan length equal true length. Whenever a line is parallel to VP, elevation length equal true length. Whenever a line is inclined to HP, plan length is less than true length. Whenever a line is inclined to VP, elevation length is less than true length. And similarly to the profile plane. And similar to the profile plane, we call it as side view length. For the profile plane, we call it as side view length. And whenever a line is parallel to profile plane, whenever any line is parallel to profile plane, then side view length equal to true length. And whenever a line is inclined to profile plane, side view length is less than true length. Therefore, I can say that side view length is either equal to true length or less than true length, less than or equal to true length. Okay. So everyone watch this video once so that you will be understanding. I will be showing the video after the inclination with HP. Okay. Suppose this is my line, which is 0 degrees to HP. Okay. This is my letter A and letter B for the line example. Now what I'm doing is I'm giving some inclination. So this is my radius. Radius is suppose example 50 mm. Example radius 50 mm. So now I'm giving inclination. So what giving? Suppose I'm giving an inclination of 30 degrees. Listen carefully. Now I'm giving a inclination of 30 degrees. So what I do, I'll keep a protractor. First I'll mark a 30 degrees line. 30 degrees line I'll mark. Then I'll draw a 50 mm. Okay. And I'll mark this as somewhere as B dash. Example, I'll mark this as B dash because same letters I shouldn't be repeating. If I give letter B, I shouldn't give letter B, same thing. So this is a B only, so I'll be giving as B dash. Example. So this is 50 only and this is 50 only. But the angle inclination is 30 degrees. Okay. So what I can do is, instead of giving this as 50, what I do is I'll take a compass. I'll draw an angle of, I'll draw a radius. So I'll take a compass, keep my compass pointer here, and I'll keep my pencil here, and I will draw the arc. And where this arc is touching this 50, then that is the point. Okay, what I do is I'll take a protractor and I'll mark a 30 degrees line. So this is my horizontal line. I'll draw a 30 degrees line. So I don't measure with the scale. What I do is, this is my letter A. So what I do is I take a compass, I'll draw the arc. Wherever this arc is touching, this same 50 mm is transferred 50 mm this side. Because this is a radius. For the radius, the distance is same. Okay. And I'll mark this point somewhere. Okay. So what happens here is, whenever a true line makes an inclination projection. So if you see here, everyone look here. This is my letter AB. This is my letter AB. True length. True length is 50. Okay. And this is my top view. I'm seeing from the top. I'm seeing from the top view. And now I've taken an inclination of 30 degrees. Example, the theta is 30. If the theta is 30, then I'm making an inclination of 30 degrees. And what I do is, I take a compass and I make a rotation. And I'll extend this one. So that this is the intersection. I'll draw the horizontal line at this point. So this is my true length 50 mm. But if I'm seeing from the front view, I can see only this line. I can see only this line. From here to here I can see. Suppose this distance is 45. So this is when I'm seeing from the top view, whenever I'm making any inclination, theta, suppose I'm making the angle theta equal 30 degrees, then what happens is it will reduce the length. That is called, already I explained in the previous slide. So this is my plan length, top view. I'm seeing from the top view. So whenever I'm seeing the top view, the length will be reduced. Actual length is 50 mm, but when I'm rotating, this distance is true length. This is true length 50. This is true length 50, but when I'm rotating, I am seeing from the top view, this is my reduced length. So this 5 mm length is reduced when I'm seeing from the top view, because I gave the inclination. Okay, that is the same thing. So whenever it is measured along plane containing the line perpendicular to HP, it is indicated by theta. So whenever there is any angle, inclination with respect to horizontal plane, you have to give it as theta. Okay. So this is my true length. This is my true length PQ. So listen carefully. This is my true length PQ. Now what I am doing is I am taking an angle theta, I am extending angle 30 degrees. And then what I do is I take this as a compass and I'll draw the arc. And wherever this arc is touching, I have to draw the vertical line, because this is my top view. This is my top view. I'm drawing the vertical line. And this is P and Q1. Because in the top view, I need to project as small letters. and in the front view I have to project it as, small letter with the dash. And same this line I'm projecting in the front view. It will project as P dash. Same Q1 line I'm projecting in the front view, it will become as Q1 dash. Okay, because this is Q, capital letter Q. After rotating, it will become as capital letter Q1. This capital letter Q1 I'm projecting it as Q1 dash. Okay, this Q will project it as Q dash. Okay, so watch the video once, you will be understanding. So how I to project is, this Q1 dash I'm projecting down here. This is actual length, true length, and this length is the plan length, PL. Because there is an inclination, PL